Not too long ago, Craig Angulo and I decided that we were going to build a reference architecture around auto-tuning search relevance. We thought it'd be really cool if we could take the user behavior, what users are really doing in the system, use that to train an LTR model and alter the search results on the fly based on real user activity. The architecture that we built is based on the two bottom pillars of the search pyramid, the retrieval layer, where we use all the usual suspects, full text search, dense vector search, templates, ingest pipelines, semantic text field. Combining that with learn to rank and algorithm re-rankers is the core basis of the architecture. The auto-tune piece is what makes it unique and interesting. So yeah, we've got all of the cool things that we do with search, but we also have an XGBoost based LTR model that gets retrained based on agentless observability data. We're going to go ahead and have dashboards that sit on top of that, so that not only can we auto-tune relevance, but we can actually see the behavior change in the system. Now, we've reused this Search AI workflow quite a few times. It's showcased in the serverless workshop that we've developed. I first saw Sunil Manji do this in early March, where he basically showed the pattern of intelligent search queries. And we've been using it ever since. We use it in MS Build. I really like this approach to doing advanced search. You take a natural language query, you hand it to a search agent that's connected to a large language model that extracts the filters so that you can have a very precise search. In this case, we're going to use the large language model as a judge, run two different searches using two different templates, one LTR based, one not, and we're going to compare the results. Now, the auto-tune piece needs engagement data and search activity data. So what we're going to do is we created an event schema that's got the things that matter, the attributes that matter for a search, and the attributes that matter for system engagement. So if a user says, hey, I'm interested in properties number 1 and 10, have an agent contact me. We're going to log that event. We're going to use that information to retrain an LTR model. And we're also going to build ESQL dashboards that give us insight into key performance indicators like click-through rate. So I've set everything up. Hopefully you understand the goal here. We're going to auto-tune, property search, home search. Now let's dig into the demo. When I do demos, I like to do end-to-end. That way you see we're not cheating. We're actually provisioning, and the architecture has all of the core components needed in order to prove out the pattern. We have an empty Elasticsearch serverless project, no indexes, no dashboards, no inference endpoints. We wired up all of the orchestration in Mastra workflows, really cool open source tool that allows us to do things like kick off a workflow that tears down anything if it's there. In this case, it's an empty environment. Once it does that, it sets up ML inference, creates a search index, deploys search templates, loads the data. Now, the data load takes a while because we are doing ML inference on data ingestion, which is going to hit the ML inference endpoint. Last thing we do is deploy a sample dashboard so that we can actually see the user data and key performance indicators. And once this workflow finishes, we'll have a full environment that's ready for simulated load. Now that our workflow is finished running, let's see if it did what it was supposed to do. Looks like we have an index with data. Awesome. Hopefully we have a search dashboard. Sure enough, we do. And we even have our ML inference endpoint. So that first Mastra workflow of setting the environment up, executed, and did exactly what it was supposed to do. Now we'll go to the second workflow. Now this workflow, a little bit different. This is going to simulate search sessions. So we've got 100 user sessions that we're going to simulate, 5 searches per session. We set a really high click-through rate, 85%. What we're going to do is we're going to seed the data stream with real events. Then we're going to train a learn to rank model on those events, deploy the learn to rank model, and the last thing we're going to do is use a home search agent to see if the model actually behaves differently than search without LTR. It looks like we're 2 for 2. The search Autotune workflow simulated 100 search sessions, trained the LTR model, deployed the new version of the LTR model. Now we should be ready to search. So now that our workflows have run, it's time to actually run the home search agent. So we've got this wired with Gemini Pro, and we've got 2 tools that we can invoke. The search tool, which is going to do a compare contrast, run the same search using all of our templates. And then we've got a mock property engagement tool that can be used to simulate a search engagement. And we've got a long list of instructions that essentially compare the results for each template search and then grades them. So let's see how this does with our first search, affordable home. I have a feeling that the LTR template, the V4 template, is not going to do so hot with this one because the user data that we simulated was for higher priced properties. So all the engagement happened with higher, more expensive properties. And sure enough, we can see the overall relevance grade, not so good. So let's change the query and just do another super generic query, luxury home. See what the search results are now. So we can see all 3 search templates invoked. The ones we really care about are the comparison for the LTR based versus the non-LTR. And as we can see now, we're starting to get some really good results. Both the V3 template and the V4 template really shined here. You could see the low, median, and high prices are in line with higher end properties. We also have a pretty good spread for the bed and bath features, the main things that we care about. Now let's do one last search. We're going to have the filters kick in because up to this point, we really haven't done any geolocation search or even bed and bath filters in a meaningful way. So now we're running a search for a 6-bed, 6-bath, single-family home near Orlando with a garage pool under $5 million with designer finishes throughout. And wow, look at that V4 template. Now it's rocking. Why? Because it's been calibrated for high-end search properties based on the user engagement. And if we look at search tool invocation, we can see V4 template 50 miles from this lat long location, which is Orlando, Florida. 6 bedrooms, 6 baths, our price filter. We even have the features. So that's one of the things I love about the smart query pattern, about wrapping agentic search around this, because we can get some really nice testing in place when we have this stuff. And we can use the LLM as a pretty effective judge. Now, if we go to the actual dashboard, what we see is the user engagement data for today. We've got our click-through rate for each template. We've got the search response times for each template. And we can see already that the latency on the V4 template is higher than the other 2 searches. Makes sense because this is an ML model inference that happens to rescore the search results. What the actual template usage looks like percentage-wise, impressions and clicks, average click position, the top 10 queries, so we can see what users are searching for. We've got the search activity, so we can see the spikes in system usage, average result count. We can even do things like look for query tuning candidates. These are queries that might not be so great with our templates. Low result queries. These queries don't return very many results. We've got our search details that show every single search logged, and then our engagement details. Every time someone asks for more details about a specific property. All in our dashboard, all powered by ESQL, all pointing to that Elastic data stream that gives us the observability without having to really do a whole lot. No APM agents, no complex architecture, just log search events and engagement events, and you're off to the races. So now that you've seen the demo, it makes sense to walk through the workflows one more time. So we have a Mastra workflow that is responsible for setting up our Elasticsearch serverless project. We are creating an ML inference endpoint using the pre-built dense vector model. We create the search index with all of the fields that we need to load our data. And we have the copy to from text fields to semantic text that triggers the ML inference on data ingestion. We deploy our search templates that are mustache files labeled V1, V2, V3, V4. V4 is the new LTR model that we're testing. The V3 model is the tried and true 70% full text search, 30% vector search weighting with filters. And we also have our data ingestion that happens with a sample JSON-L file that's 10,000 property records, loading data in a batch size of 1,000. That second workflow, the Autotune learn to rank workflow, simulates user sessions with pre-built things like click-through rates. The simulation profile, we specified high here so that we could trigger engagement on higher end properties. We also have a bias towards the V3 template in terms of simulating the load. This event data stream data gets slurped in the LTR training process. We extract the events, we correlate this Elasticsearches with the engagement actions, create a judgment list, we build the model. Then we deploy the LTR model using ELAND. Now there's multiple steps, to make sure that we can actually deploy it and check that it's deployed. But that's essentially the workflow. Now, when you look at the LTR model under the hood and you look at the features, there are more features than what's displayed here, but these are the top 15. The interaction rate, which properties are users actually interacting with, that has the highest weighting. What position in the search was that property that was interacted with? If it's a lower position, the model is actually going to boost that in terms of importance because it shows that people are really interested in the property, even though it's not showing up in the top of the search results. The last heavily weighted feature is whether or not the title of the property overlaps with the query. And this might have something to do with why the LTR model didn't score so hot on the relevance for the test that we ran. Now, I showed you a lot of workflow stuff and showed you the search experience and the demo dashboards. What does this look like under the hood? It's a GitHub repo that's got a roughly 50-50 split in terms of TypeScript and Python code. We've got a few mustache files for our search templates. And Mastra is doing a lot of work for us. We're using it to build the actual tools that we invoke in our workflows. And we could easily convert these tools to MCP tools using Mastra. We've got all of our workflows that set everything up to power this AI search. And then we actually have the search experience itself wired into Mastra so that we can test an AI search agent. Now, what does that translate to on the Elastic serverless side? Well, all of the settings are deployed and set up. All the data is loaded. All of the auto tuning of the learn to rank model set up so we can put that behind a scheduled event or trigger it based on a certain number of events that happen in the system. The search templates getting deployed make it super easy for us to compare and contrast the search behavior at the template level. My ask is share your thoughts on this reference architecture, good and bad. And if you have an interest in digging into the code, try to run it yourself and let us know what you think.